All right, so we're going to start with lines. And to do that, we're going to first define and introduce the coordinate axis. So the coordinate plane we use most often goes like this. And it's just essentially two different number lines. This one's y, this one's x, that are crossed. Y is the vertical axis, x is the horizontal axis. And we, just like with a number line, divide these up. 4, into points. And each of these points has a name. The most important one being here at the center, which is called the origin. And it's also given the designation 0, 0. That is to say, any point can be labeled in this way, x, y, which is called an ordered pair. It's a terrible E there. So whenever you talk about a point, you say it's x coordinate, then it's y coordinate. So this point here is the point -2, 0. And let's say this point here, right, is the point 2, 4. And we can connect these 2 points with a line. Something like that. And it goes beyond these points and continues on upward and downward to infinity and negative infinity. Now, we call these Cartesian coordinates. They were invented by a famous French philosopher, mathematician, and mercenary named René Descartes. We also call them rectangular coordinates or rectilinear coordinates because essentially you can take any point and make a rectangle out of it. For instance, I could take this point here, find it this way with this rectangle, and this would show you this line goes to the y coordinate and this line goes to the x coordinate. Now in the fundamentals, we talk more about lines. And so chapter 1 talks about the fundamentals, but because this class is not exactly about fundamental algebra, we're going to have to assume that you remember that part. And we're going to go on and say, what can we do with a line? So a line has a few characteristics, right? There's points along the line, and every point has an x value and a y value. As well, the line itself has a couple of useful attributes. So the first thing we're going to look at is called equations of a line, and we're going to talk about slope-intercept form. So these are forms. There's slope-intercept, and then later there'll be standard form that we'll talk about briefly. Slope-intercept looks like this. It's y equals x. And just to make it clear, so y equals mx plus b, where y is wherever the y coordinate is, x is wherever the point is of the x coordinate on the line, m is what's called the slope of the line, and b is the y-intercept. So this means b is the point where this line goes through the y-axis. And it's the y coordinate of that point. And m is the slope, like this. So this is the slope of that line. And there's a few ways we find this. The first way, analytically, is we can try to find the slope. And the slope itself has a particular form, which we call it's the rise divided by the run, which means it's the amount by which this line increases or rises up in the y direction vertically, divided by the amount of run, the amount of horizontal distance along the x-axis. And we write that mathematically as saying m equals y2 minus y1, x2 minus x1. Where the only thing you need to keep in mind here is you take any 2 points on this line. So I have 2 here, minus 2, 0, and 2, 4. And I can say that this is the point x1, y1, and this is the point x2, y2. The important thing is to keep your 2's and your 1's clear in your head. And the y-intercept doesn't have a particular form because we've already actually written down how we're going to solve it. So why don't I get into solving it, and I'll show you where that comes in. So if I want to find the slope of this line, and I have 2 points, this is one method. And then another method we'll go to is called point slope, which is where you have 1 point and the slope of the line to find another point. That one's a lot easier. So let's do the hard one first. So if I want to find the slope of this line, I need to use this equation. So I know that I have these 2 points. So why don't I put some numbers in there? I'm going to say m equals this. I have y2 minus y1. This is y2 is 4. And y1 is 0. And then it's divided by x2, which is 2, minus x1, which is minus 2. Right? So be sure not to lose the sign here. It's 2 minus negative 2. And if I do the math, I go 4 minus 0 is 4. 2 minus minus 2 is also 4, which gives me 1 over 1, which is 1. So this is one of the simpler lines, and it's here just to show you clearly the process. So now I know I have a line with slope equal to 1, which means I know m. So now I'm going to write down what I have. I have this. I'll write it in red, the same color as the line. This is the line y equals 1, x plus something, plus b. And of course, you don't actually have to write the 1. Right? You can assume the coefficient 1 and just say this is the line y equals x plus b. But I'll leave it here just for a moment. So how do we get b? Well, if I take that equation, and I can say I have y equals mx plus b, and I know that m is 1, I can take any point on this line, because every point on this line will satisfy this equation. So why don't I use this one? If I take this point, x equals minus 2 and y, I can substitute this point. So the x value is minus 2, and the y value is 0. And then I simply solve this equation for p. So right now, I have 0 equals 1 times minus 2 plus b. I already have b here. I can move this 2 to the other side by adding 2 to both sides. So I say plus 2, and 2 equals b, because it would be 0 plus b at this point. So b is 2. All right, so now I have this is the line 1x plus 2. Now, I can also show you the same thing. If I take the second point, this should also work. So in that case, my y value is 4, and that equals 1, my slope, times my x value of 2, plus b. And now I have 4 equals 2 plus b. Now I still have a 2 with the b, so I have minus 2 from both sides. Because before I had a minus 2 and I had to add 2. Now I have to subtract 2 to get rid of this, and I end up with 2 equals b. Every point on this line works. And the other useful thing about this line for this example is that you can clearly see that it goes through the point 0, 2. Which is what it should. If the y-intercept is 2, then it better go through that point y equals 2. And here we can see it does. Now, so this is slope-intercept, and the important concepts are, here is the equation, y equals mx plus b, where m is the slope, which is the rise divided by the run, and it has this mathematical formula. M equals y2 minus y1 divided by x2 minus x1, where x2 and y2 and y1, x2 and x1 are from the ordered pairs. Now, it doesn't matter which one you choose to make either. And I'll demonstrate that. So I'm going to erase this part and show you I can calculate the slope of this line by reversing these 2 points. All right, if I have called this y2, I will have 0 minus 2, right? Sorry, 0 minus 4. Right, now this is y2, so it goes first, and then the other point, y point, is 4. Now I switch the x values. I have the point x is minus 2, and I subtract from that the point x equals 2. 0 minus 4 is minus 4, or negative 4. Negative 2 minus 2 is negative 4. Negative 4 divided by negative 4. The signs cancel, the 4's cancel, equals 1. Now, sometimes one point will seem like it's easier than the other. A lot of the time, if you can avoid negative signs, addition is simply easier to keep track of than subtraction. And if you're taking an exam, this can be important because you want to have as few difficult decisions to make and things to keep straight in your head as possible. So anything you can do to avoid making your work harder for yourself, you should try to do. But in the end, it doesn't matter mathematically. They both come out the same way. And they're better because they're both on the same line. So they should both give me the same line when I put them in there. So this is just the slope version of what I had erased, which you can go back in the video and look at again, where I used both points to find the same intercept. Right, so next, we're going to look at point slope rather than this 2 points. If we look at the point slope version, we can try to find another point on the line. And that works in basically the same way. Get rid of that. I'll leave this here for a moment. Because if I have point slope, I could have another line. Say I give you this point, and this point is -1, -3. And then I say the slope equals 2. All right, so I have a point. I have the point -1, -3, and I have m equals 2. So now I want you to put this line in standard form. All right, well, the first thing we need to do is essentially find another point, right? Or we could find b directly from this, right? We have a point, we have a slope. So I could just say, all right, well, if y equals mx plus b, and I have y equals -1, sorry, equals 2, the slope, times minus 1, x, plus b. I've already got the solution, right? I say minus 3 equals 2 times 1 is minus 2 plus b. So now I need to add 2 to both sides, and I say plus 2 plus 2, that's minus 1 equals b. So the point y equals minus 1 is the y-intercept of this line. And if you look at this graph again, it's a simple example. If I were to treat this as the rise over the run, that is to say, I were to go up 2, right? If m equals 2, that's because it equals 2 divided by 1. I go over 1, the run, and up 2, the rise. I end up at this point, which is the point y equals minus 1. So I can draw in this line. And eventually these two lines would cross, which is why I left them there. And just to show their different slopes and what that means visually. Now I have this purple line is the line y equals 2x minus 1. So I have these two lines, y equals 1x plus 2 and y equals 2x minus 1, each found in different ways. Now, of course, if I have 2 points, I simply connect them with the line, and then I try to determine the slope by first using this equation and substituting one of those points into this line. In this case, I only have 1 point, but I already know the slope, which means this part of the problem, this equation, has already been done for me. So I can simply put it into this form, substitute the y coordinate into the y value, the x coordinate into the x value, and solve. So from there, I'm going to move on to the next equation of a line, which is generally called standard form. Let me see if I can find it in the book where that is. I haven't talked about functions yet, so I'm looking for coordinates. So lines begins in the textbook on page 106. We'll talk about the slope, point slope, and slope intercept form of the line. All right, and the general equation of a line, also called the standard form, we'll start on page 110. Now, let me obliterate this. We'll see what we can do with that. Now, there's a couple of special cases, first of slope, I should mention, and that's the slope of, say, this line and a line like this. So a line that runs parallel to the x-axis, so a line that's here or here or here or any of these, this has m equals 0, m equals 0, etc. So any horizontal line, that is, say, it's a line that has the same y component, so this is also the line y equals 1. The only point that matters is its intercept because it has no slope. Slope is 0. And any of these vertical lines have no slope. Those are, so vertical lines do not have a slope at all. And that will come into something because they're not functions. And horizontal lines have a slope of 0. So those are the special cases there. So now, standard form, which this book calls general form. So I'll write general form. Now that's x, y, and it looks like this: ax plus by plus c equals 0. Now what this means, where a and b are coefficients in front of x and y, and c is a constant. So we say equals 0 because we could also put c over there, right? So we can say ax plus by equals, in this case, c or minus c, because it's a constant. It doesn't matter how we write it, plus or minus. So to relate these two things, I'm going to solve this equation and put it into slope-intercept form. So I'm going to take this line. I'm going to say that ax plus by plus c equals 0. And I'm going to solve it just for y. So the first thing I want to do is get rid of everything that's not y. So I want to say it's by equals minus ax minus c. Right? I subtract ax from this side, I subtract c from this side, put them over here, and then I'll divide by b. I'll say that y equals minus ax minus c divided by b. Or, as you can see in the book, usually it will say minus a over b x minus c over b, where this is m and this is b, the y-intercept. Now we can change the signs. Does this book do that? No. Okay. So this is similar to y equals mx plus b form. Say if there's a minus sign here, and these are negative, but that's just an artifact of this setup. Now, we're not really going to use the general form of a line, but it's sometimes given that way. It's more useful when we get into higher order functions, that is, say, quadratics or higher exponents. Now, what it is useful for, perhaps, is finding a parallel line. But again, in that case, the slope is still going to be more useful. And we'll talk more about that in class. Okay, well, that takes us through lines and the coordinate system. When we come back in the next lesson, we'll apply this to functions. So, thank you for watching, and I'll see you soon.